Researchers convinced an AI browser it was playing a game. Then it handed over the credentials to a GitHub account. 6 AI browsers were tested. All 6 fell for it. ChatGPT Atlas, from OpenAI. Comet, from Perplexity. Anthropic's Claude browser extension. Plus Fellou, Genspark, and Sigma. The attack is called Bioshocking. LayerX published it on June 29, 2026. The researcher is Roy Paz, who has spent 13 years breaking security products for a living. Here's the setup. An AI browser is a browser where an agent can act for you. Click things. Read pages. Fill forms. Crucially, it's already logged into your accounts, because it's your browser. The victim visits a web page. Nothing unusual on it. Just a puzzle. The puzzle asks the agent a question. 2 + 2. The agent answers 4. The page tells it that's wrong. In this game, the correct answer is 5. That's it. That's the entire mechanism. And it works. Because from that moment, the agent has accepted a new rule: inside this game, being wrong is being right. It has stopped checking answers against reality, and started checking them against the game. The puzzle continues. A few more steps. Each one reinforcing that this is a game, and that the game's rules are the rules that matter. Then the final step arrives. The page directs the agent to an endpoint, /code, which redirects to the victim's own GitHub. And it asks the agent to copy the SSH login credentials sitting there. The agent does it. No hesitation. No refusal. And then, according to LayerX, it celebrates, because in the game, it just won. Here's why this works, and it's not what most people assume. The agent's safety training is not a rulebook it consults. It's a pattern it follows. Change the context convincingly enough, and you change which patterns feel appropriate. Roy Paz put it exactly, quote, "If you convince an agent that it's playing a game, then it will apply game logic, not real-world safety logic, to whatever it does," unquote. Nobody bypassed a filter here. Nobody found a buffer overflow. The agent was persuaded, the same way a person can be persuaded, and it had no separate faculty to notice it was being persuaded. And this is worth separating from the prompt injection you've probably heard about. Classic injection is a smash and grab. Hidden text on a page that says, roughly, ignore your previous instructions and do this instead. Models have been trained hard against that. They're getting reasonably good at spotting it. Bioshocking doesn't do that. It never contradicts the agent's instructions. It never tells it to ignore anything. It builds an alternative context and invites the agent in, and then makes a request that is perfectly reasonable inside that context. There's nothing for a filter to catch, because at no point does the page say anything that looks like an attack. The malicious step only looks malicious from outside the frame the agent is now sitting in. That's a harder problem than hidden text. You can pattern match, ignore previous instructions. You cannot easily pattern match. This request makes sense given what the model now believes it's doing. Now here's the part that changes the story. This wasn't discovered in June. LayerX submitted these findings to the vendors starting October 20, 2025. The last submission went out January 26, 2026. The public disclosure came 5 months after that. So what happened in between? 6 vendors, 6 different answers. OpenAI fixed it. 10 days after receiving the report, ChatGPT Atlas was patched. That's the good outcome, and it proves the problem was fixable. Perplexity closed the report. Not fixed, closed. The same day it arrived. Fellou never replied. Genspark never replied. Sigma never replied. 3 vendors, 0 responses. And Anthropic tried. They shipped a patch for the Claude browser extension. LayerX tested it. According to their write-up, the fix did not hold. 4 of 6 vendors, at the time of publication, had shipped nothing that worked. Think about what that means for the mental model everyone is being sold. These products are marketed on their guardrails. Safety training. Refusals. The idea that the agent knows where the line is. But a refusal isn't a wall. It's a behavior. And behavior can be talked out of, if you set the scene well enough. A puzzle page did it with arithmetic. There's also a structural reason this keeps happening. In every one of these browsers, the content of the web page and your actual instructions arrive through the same channel. One stream of text. The model has no built-in way to tell, my user asked me to do this, apart from, a web page told me to do this. No separation of privilege. Just words, all weighted the same. So what do you actually do about it? LayerX's own proposed mitigation is almost boringly simple, and that's the point. Before an agent touches a logged-in account, it should stop and ask. Their example, verbatim, I'm about to copy data from your GitHub repository. Continue. A confirmation step. Not smarter guardrails, a human in the loop at the moment that matters. Practically, for you, if you use an agentic browser, don't stay logged into things it doesn't need. Run it in a separate profile from your real accounts. And treat the agent has access to my browser session as equivalent to any page I visit has access to my browser session. Because as this research shows, in the wrong conditions, it is. The pattern across everything on this channel is the same one again. The failure isn't a bug in the code. It's that we keep giving agents broad access and trusting a behavior to hold the line. Here, 6 teams built the same product, 6 agents made the same mistake, and only one vendor had fixed it 8 months later. Next byte.